Testing 1 2 3, testing 1 2 3. Check over here. There we go. Go get my headphones on. Get all squared away. Good. Signed in there. Signed in over here. Huh? Good. Good. Okay. Hello, everybody. So today is August 14th, 2026. It is currently 1:49 in the afternoon. 1:49 in the afternoon, ready to get started for the next set. And as you see on the clock, I've got 2 hours and 27 minutes to be able to work, and then I have another obligation coming up. So anyway, we make the best use of the time we can. So this is, I've already done 3 hours today. This is the second set. And let's go ahead and get started, shall we? Cheers. A little water. So what do we do in the stream? We are engaged in the process of doing a little bit of math review, and I am using this as a multiple opportunity to not only work on mathematics, but also on a skill that I think is vital for bringing the benefits of handwriting into the mainstream without any of the downsides of longhand. So you have all the benefits of being able to write and being able to get the neuromuscular benefits of handwriting, and but without any of the slowness or the cramping that it entails. So with that being said, let's go ahead and get started. I am using Augustus De Morgan's The Elements of Arithmetic. There's a link down in the description in case you are interested, if you want to take a look at that. There's also a link down below to some wonderful resources for learning Gregg shorthand if you are so inclined. If not, you're welcome to just watch me as I demonstrate the process of writing. I'm relatively new to the domain of shorthand, especially taking it more seriously. Been a hobbyist for far too long. And anyway, so now I'm attempting to incorporate it into my regular workflow, so to speak. So with that, let's go ahead and get started. I am currently on paragraph number 53, I believe it is. Take a look here. No, 55. And we're just finishing up paragraph 55. We're talking about the ability to split information in the split the numbers into different groupings to help you with solving multiplication problems. Okay, so in figure 2, and the figures that they are referencing are listed here. So we have figure 1 is both of them together, A and B. As you see, we have these 56 rams here, and then figure 2 is the four groupings. Okay, so we have a total of 56, 7 in each row, and then there are a total of 8 or 7 in each column, and then 8 in the rows. All right, so let's go ahead and begin. Going down here, scroll down to the page where we were, 28, or twice 28, or 28 times 2, or 7 first multiplied by 4. So we continue, or 7 first multiplied by 4, okay, and that product multiplied by 2, and that product multiplied by 2. Period. In figure 2, it is shown that 7 multiplied by 8 In figure 2, okay, it is shown that 7 multiplied by 8, it is shown that 7 multiplied by 8 is also 7 first multiplied by 2 and that product multiplied by 4 and that product multiplied by 4. The same method may be applied to other numbers. The same method may be applied to other numbers. Period. Thus, let's go ahead and clean that up a little bit. Thus, since 80 is 8 times 10, thus, since 80 is 8 times 10, 256 times 80 is 256 multiplied by 8. And that product is multiplied by 10. And that product is multiplied by 10, period. If we use the signs, if we use the signs, the foregoing assertions and then assertions, A-S-E-R, it might be the whole thing, so let me go ahead and write it out and then we'll see. We go assertions, let's see if that is correct. There's assert and then assertion. Okay, so it's just AS and then shun. Okay. The foregoing assertions are made thus, colon. Seven times 8 is equal to 7 times 4 times 2, which is 7 times 2 times 4. So these assertions, and this is the idea that you can break, it's the same idea as products, right? So we have 7 times 8. Well, this is going to be equal to 7 times 4 times 2, what we would consider the factors of 8, which is then equal to 7 times 2 times 4. Okay? So those are all the same. In other words, the factors, you can multiply the factors. And then if you have 256, so this is a new line, okay? And this is 256 is equal to 256 times 8 times 10, or another way would be 256 times 10 times 8. Okay? And then we have some exercises. We do not need to worry about those exercises. We're going to skip those for now because we're just doing the copywork, okay? So we can go ahead and move on to Article 56, but before I do that, let me go ahead and read. I'm going to read through Article 55. Here we go. Beginning of Article 55 is, there it is. Okay, let's begin. Finish saving. I might have to delete all those images because that is taking a long time. It's taking a long time. So let's go ahead and get started. Grab our highlighter. Here we go. 55. It is another way in which there is another way in which two numbers may be multiplied together. Since 8 is 4 times 2, 7 times 8 may be made by multiplying 7 and 4, and then multiplying that product by 2. To show this, place 7 counters in a line, and this is what our counters were, and repeat that line in all 8 times. In all 8 times. As in figure 1 and 2. So you see here, those are the different forms we have, right? So we have a total of 7 in a row, or 7 items in a row, and then there are 8 rows total, okay? The number of counters in all is 8 times 7, or 56, but by as in, is that but as in? But as in figure 1. There we go. But as in figure 1, and by figure 1, they're talking about here, okay? So that's our teal colored, right? That's the teal colored box in the video. So figure 1, okay? As in figure 1, enclose each 4 rows, enclose each 4, each 4 rows in oblong figures, call those rectangles, such as A and B. We did that. And then the number in each oblong is 4 times 7, or 28. And there are 2 of these oblongs, so that in the whole, the number of counters is twice 28, or 28 times 2, or 7, first multiplied by 4, and that product multiplied by 2. In figure 2, it is shown that in 7 multiplied by 8 is also 7 first multiplied by 2, then that product multiplied by 4. The same method may be applied, and applied net needs to be just a little bigger. There you go. May be applied to other numbers. Thus, since 80 is 8 times 10, 256 times 80 is, and that's times, there we go, 256 times 80 is 256 multiplied by 8, and that product is multiplied by 10. If we use the signs, the foregoing assertions are made thus. And then we have 7 times 8 is equal to 7 times 4 times 2, which is equal to 7 times 2 times 4. And then 256 is equal to 256. Oh, wait. 250, that's not correct. I messed that up. That should be 256 is equal, right? To 80? Yes, so I need to fix that. So I might have to write it a little bit smaller. 256 times 80, okay? 256 times 80 is equal to 256 times 8 times 10, which is equal to 256 times 8 times 10 times 8. And that was the paragraph number 55, okay? I'm going to skip those exercises. Like I said, go on to 56. Articles 51 and 55. Now, before I do that, because we're done with the previous section, I am going to go ahead and delete those images. The reason for that is because they're just using too much processing power, and the Zernal is struggling a little bit, so we'll have to say bye-bye to our rams for now, and we'll also do the same with the doves, and I'll probably just have to do dots if I want to do counters going forward. So, goodbye. It's nice knowing you. All right, so now we can just keep on going. So we go to 56. So we have 56 pulled up here. And articles 51 and 55 is what we have here. Articles 51 and 55. 55, maybe, yeah, it's much faster. Maybe expressed. Expressed was expr, right? I forgot that one. Yes. Maybe expressed in the following way. In the following way, comma, whereby AB, whereby A, B, we mean A taken B times. A taken B times by ABC by A, B, and C. A taken B times and the result taken C times. A taken B times and the result taken C times, and the result taken C times, period. Then we can show this as below. Let's go ahead and add a line. This is Elements of Arithmetic, section 3, page 6. Go back up. AB is equal to BA. AB is equal to BA. And then ABC is equal to ACB, which is equal to BCA, which is equal to, was that the final one? Yeah, BAC, and then etc., etc. Okay? Or we can actually do this symbol there, so that one would be, there we go, and that's the symbol for etc. and following. And then the final one would be ABC. ABC is equal to A times, and then looking at the results of B and C, okay, and that would then be the same as B times C times A. So we're just seeing this one's called the law, this is called the communicative law. So C times A, which is then equal to C times, and then in parentheses, it's going to be A and B. Barely fit it in there, but I think we just managed. So we can see what that looks like right there. And we scroll down. All right. So if we, before I go on, I do want to show this as the communicative law. Okay. So let's actually look up that and see if it's in the dictionary. If not, then I will add it later, but let's go ahead and check. Looking for communicative. There it is. You see, it's a second line down, communicative. And so this is the communicative law. And it's just communa, and then V ending for cative. This is communicative law, okay? And the communicative law states that for any two numbers, A and B, it does not matter in what order they are multiplied, okay? So you could have A, B, or you could have B, A. And it makes no difference whatsoever. The order of a number does not change its rules when they're bound by multiplication. That is the communicative law. That is the communicative law. Let's go back. And, oh, I need to grab this, and I need to put this on the, I'm going to cut this, and we're going to paste this over here on the next line, the next column. Right here, paste. There we go. All right, so there is the communicative law. Keep on going. Grab a little sip of water first. Okay, let's proceed. If we say that the same results are produced by multiplying by B, C, and D, if we say that the same results and results are produced by multiplying by B, C, and D, and D, one after the other, comma, and by the product BCD, and by the product BCD at once, comma, we write the following. We write the following, semicolon, and then this one we'll probably do on the line below. So we go A times B times C times D is equal to A, and then we group these, times B, C, and D. The fact is that if any numbers are to be multiplied together, the fact is that if any numbers are to be multiplied together, that if any numbers are to be multiplied together, comma, the product of any two or more may be formed. The product of two or more may be formed, comma, and substituted, and substitute, isn't that the one where we go S and then TUT? Something like that. Let's check it. Nope, it's just SST doubled. May be substituted, and we can actually then extend that out even further. May be substituted instead of those two or more. Instead of those two or more. Thus, the product A, B, C, D, E, and F, A, B, C, D, E, F may be formed by multiplying by multiplying, and then it lays out the form, and then it gives all the different directions. Okay, so we'll go ahead and lay that out. So A, B, C, D, E, and F. So we have this grouping here, and it's just showing the idea of products, or factors actually. A, B, and then C, C, D, E, and then F over here, and then we have A, B, and F could go here, and then we would have D here, D and E, and then C right over here, and then over here we would have A, B, and C, and then D, E, F in the center. So once again, we're just showing, oh, that's B and B, rats. This is, I rewrote it. It should be D going this way. There's D, and then D, E, F, D, E, and F, like that. And then it would be etc. Right? Yeah. Etc. And then C. Okay? Okay, so there we go. Those are all the different forms that can take. Now let's go ahead and read back over. That's Article 56. So let's go back and reread Article 56, starting here. Let us begin. 56. Articles 51 and 55 may be explained or expressed in the following way, whereby A, B, we mean A taken B times, but ABC by ABC, A taken B times, and the result taken C times. If that is the case, then we have AB is equal to BA, and we have ABC is equal to ACB, which is equal to BCA, which is equal to BAC, and etc. ABC is equal to A times, and then we group B and C, which would then be equal to B times, and then the grouping of C and A, which is equal to C times the grouping of A and B. Okay, going on. And then this law here is that thereby is explaining the communicative law. All right, if we say that the same results are produced, let me check produced just to confirm. That is correct, and then produced, you simply add the T to it. Good. Going on. Are produced by multiplying by B, C, and D, one after the other, and by the product BCD, it at once we write the following. This is the following. A times B times C times D is equal to A times and the grouping of B, C, and D. The fact is that if any numbers are to be multiplied together, the product of two or more may be formed and substituted instead of the two or more. Thus, the product A, B, C, D, E, F may be formed by multiplying So we could form that by multiplying first A and B, and then C, D, and E, then F, or we could multiply ABF times D and E times C, or finally we could multiply it this way, which would be ABAD, is that ABC, and DEF, etc., etc. Okay? Good, good. Moving on, this is paragraph number 57. Okay? Drop a paragraph marker and highlight, and we do 57. 57. In order to multiply by 10, in order to multiply by 10, annex a cipher to the right hand of the multiplicand. Oh, there's two big words there. Let's try annex. There's annex. That's annexation, so we can just do annex like that. There we go. Annex, which reminds me, I need to add that to the dictionary then. Okay, there's annex. Annex, a cipher to the right hand of the multiplicand. To the right hand of the multiplicand. There's a word for you, multiplicand. So that's multa, and then plicand, I believe. Let's go check. That's correct. Good. To the multiplicand. And then he has an example. So we'll move this up here. Thus, 10 times 2,356 is did I do an is already? No, I didn't, so I need to do an is here. Is 23,560. 23,560. Okay? Period. To show this, comma, write 256 at length, 2,356 at length, which is, and then go down. So we write it out this way. Same thing as before. Like, I think we did this yesterday, right? Where we did 2 thousands, 3 hundreds, 5 tens, 5 tens, and 6 units. Okay? Take each of these parts 10 times. Take each of these parts 10 times, comma, which, comma, by 52, and that's paragraph 52, remember? By paragraph 52, comma, is the same as multiplying the whole number, is the same as multiplying the whole number by 10, and it will then be by 10, and it will then be, and it will then become, second line down, 2 tens of thousands, so that would be 2 10,000s, 3 1000s, right? 3 1000s, 5 10 10 tens, right? Tens of tens. So we'll do that here. 10 tens. And 6 tens and 6 tens, which is, and then if you write it out, 2, it just shifted everything over 1. So we have 2 10,000s, 3 thousands, 5 hundreds, and 6 tens, and 6 tens. Okay? All right, moving on. This must be written 23,560. This must be written, here we go, this must be written 23,560 because 6 is not to be 6 units. Because 6 is not to be 6 units, comma, but 6 tens, period. Therefore, 23,056 times 10 is equal to 200. So 2,356 times 10 is equal to 23,560. There we go. Good. Next paragraph down. In this way, you may show, so we have in this way, you may show, that in order to multiply by 100, that in order to multiply by 100, you must affix, and affix would be affix 2 ciphers to the right. To the right, semicolon. To multiply by 1,000, you must affix 3 ciphers, and so on. To multiply by 1,000, you must affix 3 ciphers and so on. Period. The rule will be best caught from the following table. The rule will be best caught from the following table. Okay, I'm not going to copy the table. You may if you wish, as you see that. So I'm not gonna actually bother with that. We will skip it for now. Okay, so let's keep on going. Let's keep on going. Okay, so we can just go ahead and go back before I continue on with the next value. We're going to go ahead and reread or read through 57. Okay, here we go. Article 57. In order to multiply by 10 nx, and let's put the dot for the article. Nx, the cipher to the right hand of the multiplicand. Thus, 10 times 2,356 is 23,560. To show this, write 2,356 at length, which is, and let's make that just a little longer. At length, which is 2 thousands, 3 hundreds, 5 tens, and 6 units. That take each of these parts 10 times, which by 52 is the same as multiplying the whole number by 10, and it will then make then just a little shorter, and it will then become 2 10,000s, 3 1000s, 5 tens of 5 tens of tens, and 6 tens. And each of those is tens of tens. So this becomes tens, tens, tens of tens, so on and so forth. And then if we simplify, we get 2 10,000, 3,000, 5 hundreds, 5 hundreds, and 6 tens. This must be written 23,560 because 6 is not to be 6 units, but 6 tens. Therefore, 2,356 times 10 is equal to 23,560. And then next article was, or the next paragraph was, in this way you may show that no order to, you may show that what is that? You may show that in order to multiply by 100, you must affix 2 ciphers to the right. To multiply by 1,000, you must affix 3 ciphers, and so on. The rule will be best. What's the word there? Will be best caught? No. Yeah, will be best caught from the following table. And I'm just going to make a note in here, check textbook. So we're going to have check textbook, okay? And I'm just going to put that in parentheses. All right, good. So that takes care of that. So I need to add another page below here, page number 7. This is Elements of Arithmetic. Section 3, page number 7. Back up. Okay, continuing on. I will now show how to multiply by one of the numbers 2, 3, 4, 5, and 9. I do not include 1 because multiplying by 1 or taking the number once is what is meant. Okay, so let's go ahead and show these. Let's continue. 58. Okay. I now show how to multiply by one of the numbers. I now show how to multiply by one of the numbers 2, 3, 4, 5, 6, 7, 8, and 9, or 9, or 9. I do not include 1. I do not include. Let's check and see if that is include. Oh, that's right. Boy, I tell you, and I was so proud of myself last week. I remembered include all on my own, and then I forget it now. Here we go. I do not include 1, comma, because multiplying by 1 or taking the number once, or taking the number once, comma, is what is meant by simply writing down the number. Is what is meant? Is that meant? Oh, what is meant? Let's see. Oh, yeah, duh. Okay, is what is meant by simply writing down the number. Writing down the number, period. I want to multiply. I want to multiply 1,368 by 8. Okay? Write the first number at full length. Write the first number at full is that F? Is that full? Let's check that out. No, no, no. It is shortened. It's just the U hook, okay? At full length. Write the number at full length, which is, and then we write it out. So this is 1,000. 1,000. 3. Oh, 1,000 does not have to have the S unless it's plural. 1,000, 300s, 6 tens, and 8 units. There we go. Okay, let's go ahead and put that more centralized, move the whole unit over. There we go. 1,300s, and once again that aspirate, man. All right, to multiply this by 8, to multiply this by 8, comma, multiply each of these parts, each of these, and of these would actually, that's a really good phrase, of these parts by 8, and that was according to Article 50, according to Article 50, and Article 52, and Article 52, okay, comma, which will give, zoom down the line a little bit, which will give, and then if we lay it out, 8 thousands, hold on, gotta check out, that's thousands, right? Thousands is just by itself, I think. Let's see here. That's thousands, and then thousands. Okay, so yeah, so that's thousands, plural. 2,400s. Okay, so 8,000s. 2,400s, right? 48 tens. 48 tens. And 64 units. Okay, now 64 units are written thus. Here's our next line. Now 64 units are written thus, as 64 are written thus as 64. 48 tens, so we're just saying the same thing, it's laid out, so 48 tens is 480, and next line down, 2,400s is, so we have 2,400s, okay, is written as 2,400, 2,400, okay, and then 8,000s is of course written as 8,000, 8,000, once you expand it out, okay? Add these together, which gives, so, oh boy, I gotta work on lining up my columns here. Oh, that's disgusting. All right, let's go ahead and fix that here. So we'll line them up. We need 64 is here, 64, and then we have 480 80, okay? And then we have 2,000, oh, backwards, 2,400, okay? And then we have 8,000 below that. 8,000 below, okay? And now that they're all lined up, we then need to add them in a column, okay? When you add these together, you end up with drop a 4 first, right? So we start first with the units, and then we check and our tens place, so this is going to be 14 as well, right? So we add a 4, that gives us 9. So we have 9 so far, and then we end up with 10. So this is a 0 and a 10. We check that, and we get 10,943. Okay, as the product, and that would be the product of 1,368 and 8, or 13,006, or 1,368 times 8 is equal to 10,940. So laid out this way, in fact, we'll go ahead and lay that out here. Add these together, comma, which gives 10,944. Okay, 10,944 as the product of 1,368 and 8, comma, or, and the next line down, or 1,368 times 8 is equal to 10,944. 10,944. All right, period. By working a few examples, which we're not going to do, but if you needed to, you would. By working a few examples in this way, you will see, by working a few examples in this way, you will see for the following rule, for the following, oh, come on, there we go, for the following rule, period, and we zoom down. Let's see what that following rule is. You will see for the following rule, and then 59 is the following rule. So before we go on to read that, I need to go ahead and read back over 58 once again. Arithmetic is the subject that we're copying, but the real study is shorthand as well. So comprehension is key to the learning and the acquisition of the shorthand, okay? So let's go ahead and read back over once I shake the cramp out of my hand. All right. Oh, undo. Find our last paragraph marker, which is right here, 58. All right, and we start. Once I grab a little drink of water. I have to get the cramps out of my hand and the water down my throat. Okay, here we go. Starting at 58. I now show how to multiply by one of the numbers 2, 3, 4, 5, 6, 7, 8, or 9. And done and done include, do not include? I do not, yeah. What is that supposed to be? Something include, I know. I do not include. I do not, yeah. I wonder why I got the and. That's funny. This should be I do not include. I do not include 1 because multiplying by 1 or taking the number once is what is meant by simply writing the number down. Writing down the number by simply writing. So let's go ahead and add writing by simply writing down the number. I want to multiply 1,368 by 8. Write the first number at full length, yeah, at full length, which is 1,000, 3 hundreds, 6 tens, and 8 units. To multiply this by 8, multiply each of these parts by 8, according to 50 and 52, which will give, we lay it out, 8 thousands, 24 hundreds, 48 tens, and 64 units. And then we lay it out this way, so we have now 64 units are written thus as 64, 48 tens are written as 480, 24 hundreds as 2,400, 8 thousands as this value. We line them all up in a column, and then we add the column elements in order to build out the number. So we start first with units, which would be 4. Then we start out with our tens, which is 14. Carry the 1 and carry the 1 to create 9. And then 2 plus 8 is 10. So we increase to a 10 thousandths. Add these together, which gives 10,944 as the product of 1,368 and 8, or, moving on, or 1,368 times 8 being equal to 10,944, according to using the signs, the arithmetic signs. By working a few examples in this way, we will see for the following rule, and then here's the rule as we write it down. Let's go and get started. Okay, moving down, this is 59. The first step, so this is 59, and then the first part of the rule is Roman numeral number 1. Multiply the first figure of the multiplicand by the multiplier. So we multiply the first figure, of the multiplicand by the multiplier, comma, write down the units figure and reserve the tens. Write down the units figure and reserve the tens. What is reserve? I don't know if I've done reserve before. Probably. Might be just RES, isn't it? Nope, it is RSE, so it was correct. The S goes with the V though, so we have RSV, RSEV, and reserve the tens, period. The next rule would be number 2, Roman numeral number 2. Do the same with the second figure of the multiplicand, okay? Do the same with the second figure with the second figure of the multiplicand, comma, and add to the product the number of tens, and add to the product the number of tens from the first semicolon, put down the units figure for this, of this, comma, and reserve the tens, period. Third unit, or third rule, number 3. Proceed in this way. Proceed in this way till you come to the last figure. Till you come to the last figure, comma, and then write down the whole number obtained from that figure. And then write down the whole number obtained from that figure, period. Number 4. If there be a cipher in the multiplicand, if there be a cipher in the multiplicand, comma, treat it as if it were a number, comma, what is observing? Is it just OBS? Check that. OBE, okay, observe, and then observing would just add the dot. So let's go ahead and fix that. We have observing, there we go, that 1 times 0, no, that 0 times 1 is still equal to 0. 0 times 2 is also equal to 0, etc., etc. Okay? And then, so that's the rule. That's the rule for 59. So let's go back and read, undo. Let's go back and read 59. Grab a sip of water. Okay, here we go. So, rule number 1, or part 1, is multiply the first figure of the multiplicand by the multiplier, which in this case would be the single digit, by the multiplier. Write down the units figure and reserve the tens. Then part 2, do the same with the second figure of the multiplicand, and and add to the product the number of tens from the first. The what? The something? Put down. Oh, that's put. Put down. I really need to work on that P there. Make it a little bit larger. Yeah, there we go. Put down of tens. Put down the units. Oh, what's this? Number 2. And add to the product. Add to the product the number of tens. To the product. Oh no, it is the. It wasn't put down. There we go. It was the. Huh. All right. There we go. To the product, the number of tens from the first. Here's put down. That's what it was. Put down the units figure of this. Put down the units figure of this and reserve the tens. And then here's part 3. Proceed in this way till you come to the last figure, and then write down the whole number. Write down the whole number obtained from that figure. And then this is number 4, and it says that if there be a cipher in the multiplicand, treat it as if it were, and that were is a little bit too grandiose, it were, as if it were number, observing that 0 times 1 is equal to 0, 0 times 2 is also equal to 0, etc. Okay, and now we go forward to 60. In a similar way, let's add another page. Okay, and so this is elements of arithmetic, section 3. And this one's going to be page 8. Okay. All right. That's a little too high up. It should be closer to the base. That way, if we print it off, then it will stay within the bounds of printing. Elements of arithmetic, and this is section 3 and page number 8. Jump back up. Okay, dun, and this is number 60, page, article number 60. Okay, here we go. Paragraph number or paragraph sign, and we go 60. In a similar way, in a similar way, a number can be written, no, can be multiplied by a figure which is accompanied, isn't that accompanied? Let's check and see. Yes, good. Good. All right. In a similar way, a number can be multiplied by a figure which is accompanied by ciphers, by a figure which is accompanied by ciphers, comma, as, for example, 8,000, period. For 8,000, for next line over, for 8,000 is 8 times 1,000, comma, and therefore, parenthesis, according to Article 55, you must first multiply by 8. You must first multiply by 8 and then by 1,000 and then by 1,000, okay, comma, which last operation is done, operation does require the shun ending. I'm sure it does. Oh, I'm even. It requires an Asian ending. Move this over here. Which last operation 57, according to Article 57, is done by placing 3 ciphers on the right. Is done by placing 3 ciphers on the right, period. Hence, the rule in this case is hence. So, H-E-N, hence, the rule in this case is, comma, multiply by the simple number, comma, and place the number of ciphers, and place the number of ciphers which follow it at the right, which follow it at the right of the product, period. And then here's an example, which I'm not going to write, but just know that that would work for you. So you could write it out and you simply just add the number of zeros. So you multiply out the simple figure, and then you just add the zeros to the end, okay? And I'm going to skip past. Oh, that's a word problem. That's fun. An army is made up of 30 regiments of infantry, each containing 800 men, 14 of cavalry, each containing 600 men, and 2 of artillery, each containing 300 men. The army has 6 more regiments of infantry. The enemy has 6 more regiments of infantry, each containing 100 more men, 3 more regiments of cavalry, each containing 100 men less, and 4 corps of artillery of the same magnitude as those of the first. 2 regiments of cavalry and 1 of infantry desert from the former to the latter. How many men has the second army more than the first? Oh, that's a fun one. Oh, that is great. Oh, that would be a fun assignment. I'm not going to do it now, but like I said, that would be so much fun. Look at that. That's a great word problem. You don't see stuff like that anymore. Huh. Wow. That's great. Okay, well, I'm gonna done 62. More of the same. Man, if I wasn't trying to get through, if I wasn't trying to just get my shorthand game up, then I probably would do those videos. But I really just want to lock in this skill, get it all done, so that I can then actually use it. Because right now it's just way too tenuous. So I'm gonna have to skip those exercises for right now and move on. Interesting. I wonder why the bottom value is. How long has it been showing? Huh. Well, it doesn't really matter. You can still read the material, but let's see. Oh, come on. That's funny. Huh. When did it start showing the bottom? Because it shouldn't. That's interesting. Ah, interesting. Well, let's go ahead and hide that then. No need. Odd, odd, odd. Oh, is that what it was? I had done the search. That's what it was. There we go. That's better. That's better. Aye. And this is, yeah, that's all set, ready to go. All right, so I'm going to skip past all those exercises, and we're just going to start in on second part of, what's this, measure? Not measure. Once again, don't know why I'm thinking measure. Paragraph 62. Paragraph 62, okay? So we're going to skip past, because 61 is the examples. So I'm going to skip past 61, but I'm going to make note here. In fact, I'll make a note here. So we're going to drop a little highlighter mark. And I'm going to go, I have to go take a quick break. I will be right back. Be right back. Okay, back at it. So let's continue. Taking a look at the page. Yeah, it's just messed up on that edge. So, I'm trying to remember. I don't know if I read through the previous, which is at the right. Had I read through it? I can't remember. Cipher. We'll just keep on plugging on. Okay. So I'm going to make a note about 61, that 61 is all exercises, and that I should refer to the textbook, okay? So I'm just going to make a note here. 61 is comprised. Comprised is and then PR. Comprised. Let's check that, see if that is correct. Yes, comprised, and it's a sharp one, so let's write that here. Is comprised of exercises. Consult the textbook. Consult is going to be consu, maybe? Consu for consult. Let's go check. Yep. Consult the textbook. Okay. All right. Consult the textbook. And then move on down. This is going to be 62. And 62 is going to be the same thing, where I'm not going to worry about those particular exercises, okay? Because suppose we want to multiply 23,707 by 45,067. Since 4,567 is made up of 400, 500, 600, and 7, by 53 we must multiply 23,707 by each of these and add the product. So same thing, we'll skip all that. I'm not going to write all that out. Now 58, 7 is, we simply go through and we kind of harvest them out, right? But we don't need to worry about that at the moment. So the sum of these is then, was that 1 million something? 108,269,869, which is the product required. Okay, it will do well if instead of writing the ciphers at the end of each line, so we're going to skip that, partially because in order to do the math properly, there's no reason for me to do it backwards. So I'm just going to skip. Like I said, I'm focusing on the Gregg right now, and that's the key. So we're going to do an elision to show that we've skipped a certain portion, and we're going to begin here. So an elision right there, and we start. It will do well. It will do as well if is where we start. It will do as well if, comma, instead of writing the ciphers at the end of each line, comma, we keep the other figures in their places without them. We keep the other figures in their places without them. Without them. Okay, period. If we take away the ciphers, if we take away the ciphers, comma, the second line is one place to the left. The second line is one place to the left of the first, comma, the third one place to the left, the third one place to the left of the second, to the left of the second, and so on. And so on. Period. Write the multiplier and the multiplicand. Okay, here we go. Write the multiplier and the multiplicand over these lines, comma, and the process will stand thus, and the process will stand thus, semicolon, or colon actually, and then it lays it out. So, done. So if you laid it out vertically, that's what it's talking about. If you lay them out and you just do, it's, regular multiplication. That's essentially what he's saying, okay? So we can skip that. We don't need to worry about it. Let's keep on going. Here we go. Going to 63. So we skip forward and let's go ahead and read the paragraph though before we go on, because once again, this is about shorthand, not necessarily as much about the mathematics, although the mathematics is important, but it's a review. So 62, the elision, and then we go, it will do as well if instead of writing the ciphers in the end of each line, we keep the other figures in their place. And figure, the F really needs to be a little bit more pronounced than what I'm doing. There we go. Make it just a little bit more different from an S. Figures in their places without them. If we take, right? Yeah, and need to fix we just needs to be a little bit smaller. There we go. If we take away the ciphers, the second line is one place to the left of the first, the third one, as you can see here, right? So each of them, they're laid out one level over. The second line is one place to the left of the first, the third one place to the left of the second, and so on, for as many items as we have. Write the multiplier and the multiplicand over these lines, and the process will stand thus, and then it lays out, and I'm going to just make a note, consult textbook. There we go. Open parenthesis, let's do square bracket, and once again, we're going to do consult textbook. Consult textbook. What page number? I think it's page number 31. Consult textbook, page 31. Okay. All right. Done. Now we go into 63. So let's go ahead and go to 63. Okay. So we drop a highlighter and then we mark the paragraph number as 63. And we say there is one more case to be noticed. There is one more case to be noticed. There is one more case to be noticed, semicolon. That is where there is a cipher in the middle of the multiplier. Where there is a cipher in the middle of the multiplier. Period. The following example will show that in this case, it will show that in this case, nothing more is necessary. And is necessary, it is NES, I think, right? Yes, yep, NES, and then it curves back around. Okay. Nothing more is necessary than to keep the first figure of each line in the column under the figure of the multiplier, and from which the line arises. From which the line arises. Period. Suppose it's required to multiply 365 by 1,000 by 10,001. What is that? 100, 1,001. Okay. So we have suppose, and that's SPO. Suppose it required to multiply to multiply 365 by 101,000 0 and then 1 1,000 100 1,001. The multiplier is made up of 100,000 is made up of 100,000, 1,000, and 1. Okay. All right. Proceed as before, and once again, we're going to just say consult the textbook. Proceed as before, and then in square brackets we say consult the textbook. All right. And the whole process with the ciphers struck off. Okay. Is, and same thing. I'm going to skip that entirely. We go right on through, and now we're going to do 64. But before we do that, we need to read what we wrote in 63. 63. There is one more case to be noticed. Yeah, noticed. I think notice requires an E, doesn't it? Yep. Looked a little bit too sparse. Little too sparse. To be noticed. Oh, undo. And turn off the box. There we go. To be noticed. Good. All right. That is where there is a cipher in the middle of the multiplier. The following example, so put a dot there for following. The following example will show that in this case, nothing more is necessary than to keep the, and then as it says here, than to keep the first figure of each line in the column under the figure of the multiplier from which the line arises. Suppose at Kyer? No. I think is that require? Yeah, that is required. Let me check required. It is, yeah, it does have to be disjointed. There we go. it required to multiply 365 by 100, 1001. The multiplier is made up of 100,000, 1,000, and 1. Proceed as before, and then I said consult the textbook, which is here lined up on that left-hand side. Done. There we go. And and the process will stand thus. Proceed as before, and it shows the sum, right? So you see how each of those, they simply line up each of the values, shift it over, and then you add them. And the whole process with the ciphers struck off is, and then it's 365 times 100, 1000, and 1. And you simply line it up, 365, 365, and 365, and it came. Okay, from which it came. So now, what I need to do is we need to go ahead and copy 64. I'll stretch my hand. Don't know if my hands are under more stress or something, but they feel kind of funny. Maybe it's just the weather. Okay. Probably don't need to grip the table quite as hard. So let's go to 64. So this is paragraph 64. Drop a marker. Okay. And go down here. The following is the rule in all cases. Here we go. The following is the rule in all cases. Okay? Colon. Number 1. New paragraph. New paragraph. Roman numeral. Place the multiplier under the multiplicand. Place the multiplier under the multiplicand. Just move that down here. Under the multiplicand, comma, so that the units of 1, so that the units of 1 may be under those of the other. May be under the units of, may be under those of the other. May be under, under those of the other. Period. Next paragraph, number 2. Multiply the whole multiplicand by each figure of the multiplier. So we go multiply the whole multiplicand by each figure, by each figure of the multiplier, and that was according to Article 59, comma, and place the unit of each line, and place the unit of each line in the column, under the figure of the multiplier from which it came, it came, period. That's the end of that paragraph. So new one, right? No. Then we have number 3. Add together the lines obtained from 2 column by column. So add another line. Speaking of adding, let's add another page below. Here we go. This is going to be Elements of Arithmetic, section 3, paragraph number 9. Okay, over here, add this, and this is number 3 of the rules. Okay, add together the lines obtained by 2. Add together the lines obtained by 2, column by column. Obtained by 2, column by column. Column by column, okay, period. Good. So that's the end of 64. I'm going to grab a quick drink of water, and then I go back to read it, and then starting on 65. Okay. Now, of course, remember that, once more for the record, if anyone ever goes back to watch these, this is not the way that you're supposed to study a textbook at all. The way you're supposed to study a textbook is you are supposed to read through a paragraph and then try to make a sentence in your own words that makes or that helps you comprehend the meaning of the textbook, and then you're supposed to do the examples. I'm not doing that because, in a way, as I've said, I'm using the textbook as a base material for practicing shorthand. Okay, here we go. Let's go back to 64. Here we go. 64. The following is the rule in all cases. Number 1, place the multiplier over or under the multiplicand so that the units of one may be under those of the other. Number 2, multiply the whole multiplicand by each figure of the multiplier according to Article 59, and place, that's plies, so I need to fix that, and place the unit of each line, place the units of each line, is that what it is? No, unit, yep. And place the unit of each line in the column under the figure of the multiplier from which it came. Then number 3, add together the lines obtained by 2, column by column, okay? Excellent. So now we continue, and we have 65. New paragraph. Oh. New paragraph marker. 65. All right. When the multiplier or multiplicand, when the multiplier or multiplicand, comma, or both, comma, have ciphers on the right hand, multiply the two together without the ciphers. Multiply the two together without the ciphers, comma, and then place on the right of the product all the ciphers that are on the right, and then place on the right all the on the right of the product, on the right of the product, all the ciphers that are on the right, both of the multiplier, all the ciphers that are on the right of the multiplier of the multiplier and the multiplicand, period. For example, comma, what is 3,200 times 13,000? Question. First, 3,200 is 32 times 100, or 100 times as great as, and as great would actually go as great as, SGRS for as great as. Reminds me I need to add that. Okay, so I have as great as, to check the dictionary to see if that's in there. It is, yep, and that's exactly what I thought it was going to be. Okay. Alright. 100 times as great as 32. Okay. Again, 32 times 100, 32 times 13,000. Again, 32 times 13,000 is 32 times 13, comma, with 3 ciphers affixed. With 3 ciphers affixed. Well, let's see if that's affixed. Yep, curves down just a little more than I'm doing. So let's fix that. All right, with 3 ciphers affixed, comma, that is 416. That is 416, comma, with 3 ciphers affixed, with 3 ciphers affixed, or, comma, or 416,000, or 416,000, period. But the product required, but the product required must be 100 times greater. No, must be 100 times as great. Must be 100 times as great. As great. As great as. There we go. That we have our as great as. As great as this. Or must have 2 ciphers affixed, comma, or must have, it's actually another one we're going to do, must have 2 ciphers affixed, period. It is therefore, oh boy, what is that? 1, 2, 3, done. I have to write that on the line below. 4, 1, 6, and then 1, 2, 3, 4, 5 zeros. There we go, and now we just add these. 41,600,000. Okay, nice. Having as many ciphers as were in both multiplier and multiplicand. So we have having as many ciphers as many ciphers as are in both multiplier and multiplicand, period. End of paragraph. And we go ahead and read back over that. Okay? All right. So let's go back up to 65. Dun, dun, dun. There's 65. Need to mark it. Highlighter. All right, here we go. When the multiplier or multiplicand are both have ciphers on the right hand, multiply the two together without the ciphers and then place on the right of the product all the ciphers that are on the right of the multiplier. And the multiplicand, period. For example, what is 3,200 times 13,000? And that's a question. So, oh boy, I never thought of that before. That the question and once I'm done erasing everything, that the question in Gregg's shorthand would be mistaken for a multiplication symbol, but if I put it down low enough, it should be okay. So it has to be on the line of writing. Okay, so 13,000. First, 3,200 is 32 times 100, and no, that's not right. First, or 100 times. That's an or? No, that's not an or. Oh no, I don't know what I was thinking. Or, there we go. Or 100 times, 100 times as great as 32. Again, 32 times 13,000 is 32 times 13 with what? With 3. That's right. I'm getting rid of that. I'm going straight to Arabic numerals with 3. There we go. With 3 ciphers affixed. That is 4,016 with 3 ciphers affixed, or 416,000, period. By the product required, but the product required must be 100 times as great as this, or most have, or most, what was that? Or must have, yep. Or must have, hold on, am I confusing must? Hold on, let me see here. Yeah, it's got to have just a little bit more of an undercurve. Whoop, come on. There we go. Let's curve that under just a hair. Must have, there we go. Or must have 2 ciphers affixed to affixed at affixed. Or must have, it is. It is therefore 41,600,000, having as many ciphers as are in both multiplier and multiplicand. Whew. Okay, 65. Wait, I just did 65. Yeah, let's not rewrite it. We have 66. Oh, yeah. Okay. moving down the line, moving down the line. Go ahead and add 66. Uh-huh. Ah, good. We're talking about powers now. Very nice. Already. Section 3, and we're already in powers. Great. When any number is multiplied by itself, 66. Here we go. When any number is multiplied by itself, any number of, and then times over here, times, comma, the result is called a power of that number. The result is called a power of that number, and power should be underlined, period. Thus, so we go here, thus, colon, 6, and then we have some different examples. So paragraph 6 is called the first power of 6. 6 times 6 is is the second power of 6. 6 times 6 times 6 times 6 is the third, oh, and that should curve in, no, it is in the same line, so that's third power of 6, and then 6 times 6 times 6 times 6 is the fourth power, and fourth power of 6. Okay, and etc., etc. So we have etc., etc. So each one, as you add more and more, then you end up with more and more powers, okay? The first and second, so now we go back to writing. Start here, new paragraph, and the second and third powers are usually called the square, and square is interesting. I don't know if I've done square yet. SQ, is it scare? Check. So we scroll down. S. There we go. And it's square, so it uses the W principle. Okay. Uses the square. Good. Called the square, and then cube would be the other one, which would be cube. Maybe cube. So if we go, or it could be cube. Let's go check it and see. All right, so, oh, and zoom, scroll over here, and it is that, yes, so it does use the diphthong. So we have cube are called the square and the cube. The square and the cube, all right, comma. which are incorrect names derived from certain connections, which are incorrect names. Oh, that's funny. That's a funny name. Which are incorrect names. Okay. All right. Incorrect names, comma, and derived is DRV. Let's see. I haven't done derived in a little while. Derive. There we go. Derive, and then derived is simply the D, the disjointed D below that. So we go derived from, and then certain, and then connections, connections of the second and third power from certain connections of the second and third power with the square and cube in geometry. Yep, and that one I'd heard before. The second and third power with the square and cube in geometry. Oh, in geometry, I don't know if I've done. Oh, thank you, Sean. Second and third. Let's see here. Or was that? It should be third. THE. Oh yeah. THE. Okay, so where's that? I'm looking. Second. Oh, I see what you mean. So like that. Okay, thank you. Let me... Oh, interesting. I see the reversed R principle. Okay. I don't know what I was thinking. Oh, of course, because TH is a modified T. All right, beautiful. Thank you so much, Sean. Let me go back and change that up here, right? So it was the third power, or was that? There it is. Third, good, there we go. And then fourth, excellent. All right, and where was that? Derived from certain connections of the second and third powers. Second and third. There we go. Second and third powers. Right. 10 seconds left on my end, right? Oh, nope, there's my time left. All right, so I'm going to find out what geometry is, and then I'm going to call it there for right now. So I have another job that I've got to get to, but I have to check this here. Geometry. I'm sure I'll be using that term a lot going forward. Geometry. There we go. There we go. Geometry. Come on. All right. Very nice. And that, oh, it is almost a, well, no, it's about the same length as the J stroke, so. All right. Well, I'm going to call it there. So that was, that's all I've got time for right now. And I will be back probably maybe around 7:30 and be able to put in about an hour and a half later tonight. So hope everyone's having a wonderful day. Thank you for joining in. Thank you, Sean, for that 12th hour correction. Or is it ninth hour? I forget which is. I forget which of the hours it is. But thank you so much for that. Um, it's funny. I'm making the mistakes on the forms that I think I know, and so which is almost stating the obvious. But anyway, so thank you so much, everybody. I hope everyone's having a wonderful day. I hope you're able to accomplish all that you set out to do, and I'm not sure exactly what time zones people are coming in from. Maybe they're starting a day, maybe coming coming to the end of a day. And anyway, hope you guys are all taking good care of yourselves, okay? See you in a little while. Bye-bye.